Philosopher Thomas Kuhn argued that science is a series of peaceful interludes punctuated by intellectually violent revolutions in which one conceptual worldview is replaced by another. The Structure of Scientific Revolutions, 1962. The longer-lasting, more tranquil periods of normal science are guided by a dominant paradigm. Astrophysics has been in such a peaceful interlude for decades with its belief that the universe is expanding. The expanding universe theory is a paradigm that guides how astrophysicists are thinking about the universe. As Kuhn stated further, eventually, phenomena will emerge that don't conform to the paradigm. Kuhn describes the process science then goes through. Initially, it dismisses such maverick data as anomalies or minor difficulties that science will eventually solve and fit into the paradigm. Science resists the idea that the prevailing theory and paradigm are false, and it resists alternative theories to explain the anomalies. As anomalous data increase, normal science enters a crisis. Eventually, a new paradigm that better explains the data will emerge and gain a following of scientists who will overthrow the established theory, and a scientific revolution has come about. The dominant paradigm in astrophysics is that the universe began in a Big Bang, probably from a singularity, and that the universe, the very fabric of space itself, has been expanding ever since. The expanding universe theory was developed to try to explain the observations that many galaxies display a redshift in their spectra, which scientists understandably equated with the well-established phenomena of the Doppler effect. They assumed, therefore, that a galaxy showing a redshifted spectrum is traveling away from us. The greater the redshift, the greater the speed. They also assumed that greater redshift means greater distance, a circular reasoning that we will set aside for now. That so many galaxies appear to be redshifted meant, the scientists assumed, that the whole universe is expanding, with galaxies flying away from each other. The expanding universe theory has the advantage of internal consistency. A theory's rational, mathematical beauty is beguiling to scientists. Fair enough, but for a theory to be a useful paradigm for describing reality, it must also display external consistency. Its assumptions and predictions must match observable phenomena. This is where the expanding universe theory falls short. It is not consistent with all that is the case in the universe. Anomalous data is increasingly pressing against the dominant paradigm of astrophysics. Just yesterday, news broke of yet another phenomena that does not conform with the dominant paradigm. Very old galaxies that should not exist, in fact exist, said a co-author of the study, revealing the new fact. We expected only to find tiny, young, baby galaxies at this point in time, but we've discovered galaxies as mature as our own in what was previously understood to be the dawn of the universe. I am not surprised. This is yet another big clue that the dominant paradigm about the universe expanding from a Big Bang is incorrect. The observations in the study mentioned is just one trickle in an increasing flow of data showing this. Astrophysics has many complexities, but one prediction of the expanding universe theory can be easily checked by observation, and thus the theory can be easily supported or defeated. The cosmologists tell us the universe is expanding. However, if the universe had been expanding for 12+ billion years, then we would see certain easily noticeable evidence. The expanding universe theory predicts that as space expands, the matter within space becomes less densely distributed and galaxies become farther and farther apart. Introductory astronomy courses use the analogy in the graphic to explain the theory. The claim is that every raisin is moving farther away from every other raisin. Simple enough to understand. Logically, that means that as the loaf continues to rise over time, the raisins will be further and further away from every other raisin. Therefore, as time goes by, the density of raisins within the loaf will decrease as the loaf expands, because the raisins will be spread more thinly. We see this phenomenon in rising bread dough. But do we see this in galaxies? The expanding universe theory predicts that as time goes by, the density of galaxies within the universe will decrease as the universe expands, moving galaxies further and further away from each other, spreading them more thinly across space. The universe is billions of years old. It's not as simple as watching bread dough rise, but we can indeed look at galaxy density across both space and time to support or defeat the expanding universe theory. A light year is both a measure of time and distance. If an object is 1 light year away from us, then light takes 1 year to reach us. That means that the light we see is as the object was a year ago. So when astronomers talk about galaxies billions of light years away, they also mean their observations are of those objects as they were and where they were billions of years ago. The observations of galaxies show that when we plot every observed galaxy by its distance from us, we get an even distribution. If we compare an incredibly huge section of space centered on a point 2 billion light years away with the same incredibly huge section 8 billion light years away, we see roughly the same density of galaxies 2 billion light years distant from us as 2, 3, 4, and so on billion light years distant. Because distance also equals time, that means the density of galaxies is also roughly the same 2, 3, 4, and so on. Billion years ago, so the density of galaxies is roughly the same over all eras. When we observe galaxies 8 billion light years away, we are seeing them as they were 8 billion years ago. This allows us to look back in time and very easily verify the expanding universe hypothesis. Returning to our raisin and bread dough analogy, if we measured the density of raisins per cubic centimeter in the loaf at time 0, then came 1, 2, and 3 hours later and observed that the density of raisins per cubic centimeter in the loaf had not changed, we would have to conclude that the bread dough is not rising. Any baker would be foolish to think otherwise. An analogy that was intended as an elementary example of a cosmological theory turns out to be a proof of concept that the universe is not expanding. Restating what should be obvious. This is a difficult concept to grasp, so I will restate it in different words. I have been shocked how so many astrophysicists cannot grasp these concepts, so please forgive the repetition. The expanding universe theory says that as space expands, over time, galaxies spread out and get farther from each other and become less densely packed in space. The theory predicts that we would see a lower density of galaxies 2 billion light years away than 8 billion light years away. If the universe had been expanding all that time, then the galaxies 8 billion light years away would on average be closer together than galaxies at a closer distance. It is simple to measure this, and measurements of galaxy distribution have been made. All surveys show that there is no significant change in the relative density of galaxy distribution across the universe, which means no difference over space or time. There is clumping in the universe where there are spots of greater matter density. However, the level of this clumping is the same at all distances. The density of galaxies in regions 8 billion light years away is not different from the density of galaxies in regions 2 billion light years away. Take any two distances and the same is true. Thus, since distance in space equals distance in time, the observations confirm that the density of galaxies 8 billion years ago is not different from the density of galaxies 2 billion years ago. Therefore, we must conclude that the expansion theory is contradicted by the evidence. The data indicates that the density of galaxies in the universe has not decreased over time. Galaxies are not farther apart from each other in more recent times. This defeats the expanding universe theory. The paradigm is wrong, but astrophysicists are still resisting the data showing that the prevailing theory and paradigm are false, and they resist alternative theories to explain the anomalies. Time for a revolution, or at least moving forward with a new paradigm. I have no doubt that the universe is billions of years old, but the expanding universe hypothesis is clearly false. So why do scientists continue to insist that the universe is expanding? It's classic groupthink, a common malady in all areas of human society. We see it in culture, religion, politics, and even science. Kuhn was correct. Once an idea becomes popular, it creates an inertia that makes it hard to sweep it away, even in the face of evidence. Beliefs, whether they are scientific or not, are created and maintained because they serve a useful purpose. But that purpose is not always because it best explains the available evidence. It is far too easy for people to ignore inconvenient truths if denying them serves a purpose. Sometimes, even great minds are lazy and don't ask questions. This is especially the case when great minds get together and confirmation bias takes over. Science does do a good job of correcting itself, even though it takes some time. Kuhn was correct that science is, at first, resistant to evidence that is contrary to their paradigm and contradicts their theories. Scientists are human after all too human in their psychological and rational frailties. Astrophysicists need to come up with a new paradigm, a new theory that explains the observed redshifts in galaxies. The assumption that it can be explained by the expanding universe is not compatible with other observations. What that theory should be, I cannot venture a guess, but that the current theory is wrong is easily seen, though perhaps more easily seen by those outside looking in.